Down till you see it. All right, for this first one in the bell work, what do we do? How do we solve that? Three x plus 2 equals 0. How do I solve that? Y'all, this is not the hard question up here. How do we solve this? Subtract 2 from both sides. And we get that 3x equals negative 2. What do I do next? Divide both sides by 3. And we get that x is negative 2/3. I don't know why I switched thicknesses halfway through that problem, but I did. It's a thing. It's all right. That's our solution. Whenever it says solve, what that means is get to x equals, or y equals, or whatever your variable is, equals. Solve means get to a solution here, x equals. You could wind up with more than one solution. Let's look at the second question. Hint, hint. What do we do here? We have a couple of options. What's your instinct? Those of us on our phones really need to put them away because this is not meant to be new things. What do we do here? There's a few different ways to go, so I want to know what you did. Anybody do it? Yeah, solving with square roots. That's absolutely valid. You can add 4 to both sides. That's going to give us x squared equals 4. All right, y'all, the music I'm hearing up here. Put your phones away. We have 6 weeks left until finals. We have 2 tests between now and then. I'm tired of caring more about your grades than you do. I really am. I'm so over it. What do we do here to figure out what x is? Or what is x? Square root 4. 2. Is 2 our only answer here? Is positive 2 the only thing that when squared gives us 4? Or is it positive or negative 2? When you solve with square roots, don't forget that square rooting x squared means I don't know whether it's positive or negative. Your other option up here, I said there were a few options you could do. Another option up here is to notice that this is difference of squares and factor it to be x plus 2 and x minus 2. That's also 100% a valid way to solve it. All right, we're starting a whole brand new concept right now, a whole brand new graph. that is going to be on the chapter test. It is going to be on the final. So I highly recommend we lose the headphones. We lose the phones from in front of our faces. And you know, do the thing. I need you for half an hour today. Because we're going to start graphing these things. These are rational functions, and up here it says reciprocals, because it looks like things that are upside down, but honestly, if we remember the word reciprocal, we're in a great shape. So this is the parent function for rational functions. This will be the first page in that packet that you picked up. All this information, if you want to look in your book, is on page 467. It's also in the packet. I highly recommend the packet because it gives you space to write. And it has everything kind of really condensed, and it's a lot less big. Okay? So look at this shape. It's kind of funky looking. It kind of looks like two exponential functions or an exponential function and a log function. It looks kind of like them. What it is that it has two asymptotes. You did asymptotes with Ms. Rice back when she was here. Asymptotes, remember those are the walls where our graph cannot cross it. It has a vertical asymptote and a horizontal asymptote. Two. Thank you. I don't like that. Good answer. Our asymptotes are going to be involved in our transformations, so we're going to use those an absolute boatload. But the funky thing is this shape is called a hyperbola. So it's kind of like a parabola, but it's a hyperbola. Because holy cow, there's two of them. It's gone a little hyperbola. And a hyperbola is not complete unless it has both of the swoopy things. So you got to have a swoopy thing on either side. Two asymptotes, two swoops is what it takes for a hyperbola. And our asymptotes are always going to be, and I'm going to put this up here, x equals h and y equals k. So as we do transformations, h and k are going to be incredibly important. Since this is the parent function, they're both currently sitting at 0. But x equals h and y equals k are going to be critically important. We're going to write that a few times today. Our vertical asymptote, this pink line I have up here, that one is going to be our easiest one to find. Actually, they're both pretty easy to find. Because we have one thing, whenever we have stuff inside fractions like this, there is one time I can guarantee this sucker does not work. What is the one thing in the existence of the universe we cannot divide by? 0. So we are always going to have an asymptote where our denominator is 0. So we're going to figure out, they're calling that the excluded function. Where is our denominator 0? That's what they're asking for here. So the excluded value means when is the denominator 0? What is the one thing x can't be? So looking at this first one, a, I don't have the values here. My denominator is x, so I want to know when the denominator equals 0 is when x equals 0. So x cannot equal 0. And this little symbol here, it's an equal sign with a diagonal through it. says cannot equal. X cannot equal 0. Gonna look at this denominator here. We know that x minus 7 cannot equal 0 because that's a denominator. I can't divide by 0. So what value of x makes this? X minus 7 cannot equal 0 means that x cannot equal what? Not 0. 0 minus 7 is negative 7, and I can divide by that. X cannot equal 7. You can solve this just like a regular equal sign. I can add 7 to both sides. X cannot equal 7. Give me more, because I'm not entirely sure what you mean.
Okay, so like, say for example, like, if the problem was like, wording different, it was like x plus 7,
Mhm.
and you wrote that out, and you were like, x cannot equal 2, so wouldn't it be, if like the opposite, if it'd be like, can x not equal negative 2?
Yeah, so it is always going to be the opposite sign of the expression in the denominator. It's very similar to when we would do quadratic stuff. It's all about solving it. It's kind of like the difference between the roots and the factors. Let's do one more of these, because they're going to come back into play. We'll see these a gazillion times. I want to know when this denominator equals 0. And if the equals to with the slash bothers you, you can set it up as an equals to sign. Just remember your meaning. That's the one thing x can't be. 3x plus 4 cannot equal 0. So you can solve it just like a regular thing. We can subtract 4 from both sides to get this 3x cannot equal negative 4. That's not a thing that works. So what do we do to figure out what x is? Not add. I've got 3x. Shouldn't be 4. What am I going to do to get the x by itself? Divide. Divide by 3. It's just like solving like we did in the bell work. My pen's being grumpy, guys. There we go. Because that makes my x's cancel out. Or my 3's cancel out, sorry. And we know that x cannot equal negative 4/3. X can be absolutely anything else in the existence of the universe. The only time it makes my denominator freak out is when x is negative 4/3. It could be negative 2, it could be negative 3, it could be negative 5/3. It could be 4, it could be 5 million. The only time the denominator is going to give me an error is when x is negative 4/3. Excluded values will come up every now and then. Looking at the denominator will come up pretty much daily, but the phrase excluded value is going to come up more next week than this week. Questions on this one? So we're going to start talking about transformations on these rational functions. And we are going to see our good friends that we have seen a gazillion times when talking about transformations. We have A, we have H, and we have K. They're all there. Our friends. We've seen them forever. Okay? It's the same jobs. They still do the same thing. A is our vertical stretch or compress. H is our horizontal transformation, and that tells us our vertical asymptote. This is a line on a page. So, our vertical asymptote where x equals h, it's also where our denominator equals 0. That tells us on that line up on the top, it was that pink vertical line. X equals something is a vertical line. Our horizontal asymptote comes from our k value. Our horizontal asymptote is where y equals k. It looks like this. Typically, we do asymptotes with a dashed line or a dotted line. I don't care if you do it as a solid line or a dotted line, but just make sure you draw them in. Our x-intercepts are when y equals 0. I want to know what x is when y is 0. And the y-intercept is what happens when x equals 0. You do not always have to deal with intercepts. Sometimes they're going to be a really easy way to get you some data. Sometimes they're going to not be an easy way to get data, and that's okay. Make sure you get all these blanks filled in. You're going to want to have this information. Transformation form is going to be what we focus on like for the rest of this week. We're going to do transformation form, and we're going to do graphing with transformation form. Okay. I'll do that tomorrow. So what we're going to do is we're going to look. This is that first example down below. It says consider this. And honestly, I'm going to change this for next year because I hate this one being the first because the A value is weird. Because my A value being multiplied in front of the x is actually 1/2. I hate that. If you have a number in front of your x, that means you have a fraction. So it's going to be whatever number's in front of your x and whatever's on top of the fraction as your A value. And it's gross. And it does not come up super often, but it's gross. An A of 1/2 means we are going to have a vertical compression. Our k is easy to spot. What's our k value here? 2. K is 2. Which means what happens? What does k tell us transformations-wise? Which direction does k move us? Up, down, left, or right? Up. K moves us up 2. K is also our vertical asymptote. So we're gonna have, no, I have that on the wrong line. K is our horizontal asymptote, where y equals k, y equals 2. Our h, which is why I kind of hate this question, the easiest way to find our h is to actually find our asymptote. To find that when our denominator is 0. Because it has that number in front of the x, I can't just say it's the 5. I need to know when 2x minus 5 equals 0 in order to find my asymptote. Here's the line right here because those two things are blending together. So when does 2x minus 5 equal 0? What can I do to solve this? I'm going to go ahead and walk us through it because we have 2 more to do and we really need to get to the last one today. 2x equals 5, so we add 5 to both sides. 2x equals 5. To get x by itself, divide by 2. So our asymptote is where x equals 5/2. That is our vertical asymptote. The vertical asymptote is also our h value. So h is 5/2, which means it goes right 2.5 or 5/2. The y-intercept and the x-intercept on this one are, the y-intercept in particular is fine. The x-intercept is gross. To do this, which we're not going to need to do because honestly I want to get to the other things, you would substitute in 0 for x. And solve it, which you can absolutely do. But we're not going to do that right now. There's 1, not spaced on my screen. 2, not spaced on your paper. 3, no necessary reason on this one. If you're looking for another point to graph, it's a great way to get some data. For the y-intercept, you substitute for x. For the x-intercept, you substitute for y. So let's look at the next one and identify some more transformations. This one's part B. R of x. Oh, mine says g of x up here, but your page says r of x. There we go, r of x. So look at your transformation forms. What do we have here? What's my a value? 3. Which means it has what? Stretch or compress? Is a big kid doing big kid yoga? It's so cute, I want to squish it. Is it stretched? If it's bigger than 1, it's stretched. What's our h value? What's in the denominator with the x? Or when does my denominator equal 0? When does my denominator equal 0 here? When x is what? What is subtracted from my x, my denominator? Nothing. So there's no horizontal transformation here. What's my k value? What's my k value? 1. Which means it goes up 1. We're going to write out our asymptotes. Our horizontal asymptote, and it feels backwards, is where y equals k. Y equals 1 is our horizontal asymptote. Our vertical asymptote is our x equals. And it's x equals h. So x equals 0. So it's always going to be our h and our k that are our transformations. We're gonna need those asymptotes to make the graph. They are a key part of making the graph. You have to have the asymptotes. So we have to be able to find the asymptotes, which means we have to be able to find a h and k. We are going to literally find h and k every time we graph from here to the end of the chapter. H is when your denominator is 0. K is what's added on the end. H is when your denominator is 0. K is what's added on the end. Okay? This one, again, you could find our x and y intercepts. Honestly, I'd rather go on to our very last piece of this because this is going to be our very first time graphing one of these. We're going to graph our own parent function. Tomorrow, we're going to graph more of them. But I want us to do this one first and have a little bit of time for our brain to digest it. This is our last thing for today. We're going to start with finding a, h, and k of our parent function. So I have our parent function up here at the top of my page. It's on the left side of your packet. Left side of your packet. So let's start with what is our a value for this guy here? 1. What is our h? When does our denominator equal 0? When x is by itself, when x is 0. And our k is added on the end. Let's add it over here. Nothing. Math word for nothing? 0. So we're going to have a horizontal asymptote when y equals 0 and a vertical asymptote when x equals 0. The very first thing we are going to do is graph our asymptotes every single time. Our asymptotes are going to be y equals 0. Go to our y-axis and say, all right, I'm locked in at 0. It can't go up. It can't go down. It is stuck right there at 0. My vertical asymptote's the same way. It cannot be x of 1. It cannot be x of negative 1. It is stuck. I highly recommend using a ruler on these, but I cannot on my screen. The next step we're going to do when we're graphing these is something we've not really done before. We are going to put a plus, minus around it. Because in order to figure out where our two swoops are, we have to look at our a value. Is our A value positive or is our A value negative? Positive. So we're going to circle our 2 plus signs. And anything from our asymptotes to the minus signs, I'm going to scribble out. I cannot use this space. This is for negatives only. So I'm going to cross it out. To make my hyperbola, the way we're going to do it is we are going to start from our center. It's not a dot. I'm just showing you where I am. Start from our center. We are going to go up our A value and in 1. So my A is 1. So I'm going to go from my where they cross. We're going to go up 1 and into the space I can go in and put a dot. I'm going to go down my A value and in a dot. So I'm going to start from the center, down my A, which is 1, and in. I'm going to go right my A value. So from where they cross, I'm going to go right my A value and then into the space I can go in, which I know I'm winding up exactly on top of my other dot, but it's the same. It's fine. And we're going to go left our A value. So from where they cross, left 1, and then into the space that I can. That's why it's important we cross out first. So we go up, down, and left, right, the A value. Then we're going to have, most of the time we're going to have 2 dots because our A value most of the time is not going to be 1. We're going to connect our dots and then we are going to hug our asymptotes. Asymptotes are walls we cannot cross, but we love to get as close as we can. So we're going to swoop up and down. We cannot cross the asymptotes and we cannot go into any scribbled out quadrant. It's a different way of thinking about graphs. And it's weird to wrap our brains around, which is why I didn't want to just throw the whole thing at you tomorrow. Tomorrow we will start doing this with the transformations. It's the same process. Asymptotes. X equals H, Y equals K. And we're going to do up, down, left, right, the A value. That's how we're going to graph these. We will practice these more tomorrow. We do not have a homework in particular for today. I know it says we have homework 3 today, but honestly homework 3 is all graphing, and we're going to talk about that more tomorrow. So I'm going to wait and do that tomorrow. So I have a worksheet for you with these questions on it. So you do not have to do these in the book. You can. It's the same questions. Ooh, windy. And what you could do is you could name the transformations on these. We can identify A, H, and K. We could find the asymptotes. So you can have it if you want it. Tomorrow we're going to do more of this. And I feel like it's going to be clearer tomorrow. Okay? So if you want it, I have it. This is Unit 9, Homework 3, because I'm continuing the counting since I'm still in Homework 9, or in Module 9. And then our chapter test is April the 21st. After that, we will have one more test before finals. Okay. There are 6 minutes until announcements start. Do what you need to do.